Hello, welcome. In this video we are going to see more about different mathematical environments. We can create mathematical environments using the equation command. Actual form of the equation command is /begin equation and /end equation. This pair of commands can be used, but the matter can be ended between /begin equation and the /end equation. You can see here a star is used along with the equation, along with the word equation. Why it's used and why this star is used, it is used to avoid the numbering along with that equation. If we remove that star, then you get the equation numbered in a sequential order. That we will demonstrate along with the equation, and we will demonstrate that difference using the command with star and without star. Okay. But in order to apply this command, to work this command properly, you need to use the package AMS Math. But you can see in our LATEX source code, this AMS Math package is already included, so no problem. But for a beginner, it's very important. If you are using that if you are using a program without including the AMS Math package, then it will show the error message. It will generate errors. So that's very important. You can use the command along with the package AMS Math. Okay, now we can see an example. Suppose you want to generate an output like this using this command. Suppose this is the output that you want to generate, then you can you have that source code part here. You can copy this. See, this is the ordinary matter, and then /begin equation star, and after that you can write the expression, mathematical expression, and then you can complete that command part by typing /end equation star. After that, where in $symbol A and $symbol B and $symbol C. So you can now copy it and then paste it in the program. Okay, here we are going to copy it. You can typeset it here. Okay, now we are going to take the output. Yes, at the end you can see, and here this is the output generated by that source code, that portion of the source code. So this is the mathematical expression part generated by that command. Which command? By the command /begin equation star and /end equation star. Now we are going to see the effect in the output produced when the star symbol is removed. For that you can copy that portion. See, that portion, that mathematical environment portion alone is going to be copied. I will copy that and I will paste it below this statement. And then I shall remove that star. I shall remove the star. Yes, you can see here I have removed the star symbol. The star symbols are removed from the begin and the /end statement. And when we run it, when we take the output, okay. When we take the output, yes, you can see. See, this is the mathematical expression part that we have generated, recreated. But you can see a number is appearing there on the right side. A number, and the number 1. This number, it's the label given to that mathematical expression, the first mathematical expression. So, but if you don't want this type of numbering given to that expression, then you can put a star symbol either both in the slash begin and in the slash end statement. Okay, that's the use of the star in the mathematical environment. So wherever you can, wherever you see a star operation, a star symbol used, then you can understand that it is used to avoid the label, the number label that can normally be given to the mathematical expression. Okay. Now next is yes, it is the next line here. Yeah, that is explained there without that label, without that star symbol, and it is the same thing is written there, is used there, and then but the output is not displayed here. The effect of that removing the star operation or the star symbol is not explained here. Yeah, okay, here it is given here, but here the number appears in a different way. Here you can see that label comes at the left, on the left side of that mathematical expression. Here we have that label, but that depends on the style that we are following in the LATEX program. In the LATEX system, which style is specified, and it depends on that on the numbering or the label assigned to that mathematical expression. And it depends on that style which is followed by the system. Okay, next if we come to this expression, if you want to generate this kind of expression, you can see in this case we have you can see here one ordinary sentence, and then an equation, mathematical equation, and then we have again ordinary sentence, then another equation. We can generate the output using by writing the source code, by writing the source code portion like this. Okay, and this can be then copied, and and that can be then run to obtain this output. But for that I shall first copy this. So this portion I will copy. You can see that this is thus for all real numbers x in dollar, we have slash begin equation, then the expression you can see here, and x is less than or equal to. Now let's analyze this source code portion. So in slash begin, as you come here, now you can see here the we directly type the matter up to this word, and thus for all real numbers x, but x should be in mathematical environment. Then we have, after that we have to generate the mathematical environment using slash begin equation star command. So so as you reach here, you have to type slash begin equation star, and then inside that you have x. So x is directly written. After that we have less than or equal to symbol. So for that slash le is the command used to get that symbol slash le. After that we have x in modulus symbol. So for that two vertical lines you can put inside that vertical lines you can include x. After that since we require a space two or three space of 2 or 3 characters we require. For that you can use /QUID command. So this spacing is produced by using the /QUID command. And then we have AND. This AND is not in the form of a mathematical expression. It's an ordinary matter. So that effect can be produced using the command text /text. So you have to include AND. It's very important. So if you want to produce an ordinary text inside a mathematical environment, inside again you should you should carefully listen this. If you want to create a an ordinary text inside a mathematical environment, you have to include it in the command, inside the command /text. /text is the command, and then in curly bracket you can include that matter, the material that should appear as an ordinary text inside the mathematical environment, and that is here done using that command. After that you need a space. So for that we use /QUID command once again. Then you have to type x. Then we have greater than or equal to. So GE is the command for that, for producing this symbol. So x/GE. After that then modulus of x you have to type. Since we reach the end of that mathematical expression, you can close that by putting /end equation /end, then bracket, in curly bracket, equation star is written. After that we come to this line, and so. See, the line you have to type is and so is as usual, it is written, and so it is typed. After that you come to, after completing the typing up to this level, you come to a new equation environment, a similar new equation environment. Here we have to type x less than or equal to modulus of x, then space for all x in capital R in the set of real numbers R. And this R is not an ordinary R, it's a special kind of R, and that stands for the set of all real numbers. So we begin another mathematical environment /begin equation star. Then you can type x. After that /LE less than or equal to is represented by using the command /LE. After that you can put the vertical line, then x, and again another vertical line. Then you need a space that can be created using /QUID, and then you can see for all is an ordinary matter, an ordinary text, not in the form of a mathematical expression. So you can include it using the command /text in curly bracket for all. See, /text in curly bracket, you have to type it for all. After that then x. Okay, that also, that you can either you can close that curly bracket here, or you can include the entire thing inside that curly bracket, and then you can again use mathematical environments inside, because if you are including for all x in R and the entire thing inside that /text, then it will act like an ordinary text. So again, if you want to, since x is in the form of a mathematical expression, you have to put $x, and you have to include x enclosed by $, and also you have to include R enclosed by $. symbol. So that is the important thing that you have to remember. Therefore, to get the effect of the entire LATEX source code, you can copy and paste it in the here in the program file. It is then typed. Okay, then I am going to take the output. See, you can see this portion. Okay, yeah, we have obtained that output. see here, that line, you have to adjust that line. Okay, one space, by providing a space after that line, then you get that effect. Okay, see, after that line, after the line, that the new output is now obtained. The new output, it's obtained here. You can see it appears as it is provided in the LaTeX manual. Okay, then if you want to typeset this kind of lengthy expression, this kind of lengthy expression, then you can use the corresponding command. The corresponding command part can be a new command can be used to typeset. There is no need to use that one, but now we are going to introduce a new command, a new mathematical environment, a different mathematical environment, because knowing all the mathematical environment is very important. You can choose the best mathematical environment, best command which can create the better effect in depending upon the situation. Depending on the situation that you are going to face, you have to choose the best command or the method to create the mathematical environment. That's why we need to study all the important mathematical environment commands. So here you can see we are going to learn another mathematical environment. That mathematical environment is multiline, along with the star. If you don't want to create the number as label, any number as label for that mathematical expression, you can use the star along with the multiline. So the multiline command that you can see here, it is written as /begin multiline star, /begin multiline star, and then /end multiline star is the command, /begin multiline, and then the type written portion that will create this output. Here you can see many squares and exponentiation is there, so at many places. Naturally, then you can think that there are caps used at many places. So you have to be careful about that manual typing of the cap, because that will create problem. So I am going to I have now copied it. I am going to copy and paste it. You can see /begin multiline star, and that ends with that the end command. Okay, here you have the a square, but you have a cap here. You can replace it by the correct cap, a square, that is a cap 2, then b cap 2, b cap 2, okay, then c cap 2, and then d cap 2, okay, after that e cap 2, okay. And this is the expression a plus in bracket. You can, by analyzing the expression inside that begin and end commands, begin multiline and end multiline command, you can see that the first line contains a plus b plus c plus d plus e in bracket, and then the whole square is typed. Cap 2 is typed. Cap 2 means the whole square equals a cap 2 plus b cap 2, that is a square plus b square, plus c cap 2 plus d cap 2 plus d e cap 2. Then you can see paired backslashes are used. Paired backslashes, that stands for or that can create the effect of new line. So the matter that we type after this paired backslashes, all this matter will go to the next line. And you can see here plus 2ab plus 2ac etc., and these other terms typed there. So all those things will be displayed in the next line. Now we are going to take the output. The previous output should be cancelled before that. Okay, then taking the output. we can see this is the output generated by that source code. Okay. Okay, next we have to discuss next we are going to discuss another mathematical environment. Okay, but the same mathematical environment, the multiline itself, but that will generate the output that can be used to multiline environment can generate an output like this, which is given, which is displayed here. And see the matter which is displayed inside that square bag, inside the rectangle. That output contains many lines, multiple lines of expressions you can see here. One thing is that the first line contains a lengthy expression, but that line is aligned to the left, you can see. But the second line, third line, fourth line, and fifth line, second, third, fourth, and fifth, and next 4 lines are centralized. See, these lines are centralized, but the last line you can see that it is right aligned. So the first line is left aligned and the right line is the last line is right aligned, but all the remaining, the middle lines are centralized. And this is the structure of the output that you are going to get when you use the multiline command. But when you use the multiline command, in full form it is a /begin multiline star and /end multiline star command to generate multiple lines of mathematical expressions. So in order to verify this, you can copy this expression and paste it in the program, and we will run it. So we want to give a separation. So separating line is given, and then we just copy it. Okay, then why that? Okay,